All right, everybody, I'm back. I've got some sad news. I did not close that Zoom meeting, the third segment, properly, and I don't believe we have a video for it. I will do my best to recreate that segment later, and I'll post the 3 segments today that we did successfully do. I forgot to shut off the shared screen, and then I closed Zoom, and I think that prevents the Zoom share. Anyway, moving on, we're going to finish off with a little nomenclature review. Little nomenclature review. And we'll take it from the start of the semester from Orgo 1. Yeah, I got the straightening tool on. Not good for zigzags. All right. And simple stereo center there. So when we're naming these things, got to do your numbering first. Carbon 3 to get the methyl group on the lowest possible number, carbon 6. And the stereo center priorities go 4 for a hydrogen, 3 for a carbon with nothing but hydrogens, 2 for a carbon with another carbon, but that second carbon is a CH3, and 1 for a carbon that goes to a CH2 that has yet another carbon. And I was nice and put the stereo center with the number 4 on a dash. That makes this an S stereo center. And there's a methyl on carbon 3. Of a 6-carbon chain. And that was our earliest nomenclature, alkanes. Then we got into alkenes. And why not have a stereo center on there as well? So we get that. Numbering directions important here. If you go right to left, the alkene, I could have made it a better example. Let's just add a carbon here. So it is different. You'd get a lower alkene number from the left, and you'd get a lower group number from the right. Which one's more important? Well, the alkene is. So we're going from the left. That puts this as carbon 4, 5, 6, 7, and 9. It's a nonane. And a group with 3 fluorines on a single carbon group is called a trifluoromethyl group. Hopefully this fits. Trifluoromethyl. There's 2 of them. That's not very nice. Ditrifluoromethyl. You have to indicate which carbon numbers in the chain have the groups. You have to indicate the stereo center has an S name. This one goes 1 for a carbon with a fluorine, 2 for a carbon that goes to a longer chain, has a double bond, 4 for the H, Remember, 4 doesn't have to be an H, just our first two examples it was. 3 would be the ethyl here. So that's an S stereocenter on carbon 7. There's a double bond with geometry between carbons 4 and 5. Now this is a double bond that has 3 carbon groups attached, 3 groups. I wouldn't use cis or trans there, although I would accept a cis answer here. Let's put it in pink. I will accept a cis answer, but I would prefer an EZ. That's a wow, simple letter like an O, sometimes not so easy. I'm leaving it. To do E and Z, we've got to break the double bond in half. Put the missing H on. H gets a 2 priority. Carbon gets a 1. Carbon with a fluorine gets a 1. Carbon with a carbon, just carbon without a fluorine, gets a 2. The 1s are on opposite sides. The stereocenter, sorry, the alkene with geometry on carbon 4 is an E alkene. Okay. Or you could say cis. Not all E's are cis. Not all E's are trans. They are totally different systems. The cis relates to the chain entering from the bottom and exiting also from the bottom. Entering and exiting on the same side is cis. Entering and exiting on opposite sides is trans. The EZ system's a little more systematic. So that's alkenes. Next thing we encountered, we had alkyl halides in chapter 7. We had alkyl halides in chapter 8. We had alkynes in chapter 7. Alkyne nomenclature is even simpler than alkenes because geometry is not an issue. So let's do a simple one here. That kind of alkyne is called a terminal alkyne, as opposed to an internal alkyne. Terminal is the one where there's a pKa, 25. Internal, you can't take an H where you don't have one, so there's no pKa's for here. You'd have to say this molecule is a 50 because you can only take it from the alkene portions of the molecule. Anyway, this is a nomenclature review, not a pKa review, but I sneak in review all the time. All right, the alkyne's the most important. Whoa, I hit a button. Alkyne 3, 4, 5, and 6. This is 5-methyl. It's atrocious writing. Got to work on that. 1-hexyne. Or alkynes can be named after the parent, which is acetylene. And then you name the group attached to acetylene. Remember, acetylene is just the alkyne. And this is an iso group attached, an iso with 5 carbons. 1, 2, 3, 4, 5. Isopentyl acetylene. It's chapter 7. Chapter 7. Above was chapter 6. Above, chapter 2. In our next example, they both put an alkyne on carbon 4 from the left or the right. 1, 2, 3, 4, or 1, 2, 3, 4. But you get a group on this one. If you go left to right, you get a group on 2. You wouldn't hit that group until 4, 5, 6, 7 here. So I like the 2 better than the 7. Got the alkyne on 4, 5, 6, 7, 8. So it's octyne. So we can go 4 octyne. And I forgot to bring it up in the previous example. It's always acceptable to move the 4 closer to the yne. And there's a methyl group on 2. My H's are my worst letter, aren't they? And same story here. There. Using the other system, we have an isobutyl on the left of carbon 4. And we have a propyl on the right of carbon 5. So isobutyl, propyl, separate word, and separate word again. I don't think I was very clear in my first example. E's are also tricky. Should be a more noticeable space in there. No comment. I don't grade such things very harshly. In fact, I don't think, if you had one word there for that first one, I wouldn't take any points off. Okay, that's chapter 7. Chapter 8, really, we studied alkyl halides earlier in the course. We introduced them in chapter 2. And might as well throw one here just to have something for chapter 8. Oh, we did do one new thing in chapter 8. If all of the hydrogens have been replaced by halogens, there's a quicker way than to say, and you can go with a UPAC name, which is, it's going to be tedious. 1, 1, 1, 2, 2, 3, 3, 3. There's all the positions of the bromines. That's 8 bromines, octabromo. Propane. Or if all of the hydrogens have been replaced with halogens, per bromo propane. There you go. I probably will not be putting that on a test. That's a 241 item only. That's nice to know. Chapter 9. No new nomenclature there. That was just analysis of reactions. Chapter 10. We had alcohols. Let's see what happens if we have a little bit of everything in our alcohol. Alkyne. Alkene. Alcohol. Alcohols have the highest priority in organic chemistry 1 because oxygen-containing functional groups have higher priority, and a good generalization for your future studies in orgo 2. are that the more bonds you have to oxygen, the higher the priority in terms of nomenclature. So an aldehyde or a ketone that has 2 bonds to O would have a higher priority than an alcohol. That's coming up in chapter 16. And carboxylic acids with 3 bonds to O, you have the double bond to O and another single bond to O, have an even higher priority than aldehydes and ketones. That'll be coming up in chapter 17. And then again in chapter 18, derivatives of carboxylic acids have the same priority as carboxylic acids. So a little preview there. And in this one, all that discussion was just to say, start on the right of this molecule, making this a carbon 2 and a 4, 5, 6, 7, and an 8. So how do we say we have an 8 carbon molecule? Well, it's always going to end with some kind of oct. And there's a double bond between 4 and 5. En. There's a triple bond between 7 and 8. And there is an alcohol on carbon 2. Notice our ene didn't end with the letter E because it wasn't the end of the word. Our eine doesn't end with the letter E because it's not the end of the word. And alcohol doesn't end with an E, so we never see an E at the end on this one. 2-OL. OL at the end because alcohol has the highest priority. And all that remains now is for our stereocenter and our double bond geometry. Stereocenters on carbon 2. Double bond geometry is on 4. Stereocenter is S. Double bond is cis. In this case, with simple alkenes, this is the only time you can say this. A simple alkene where it's just the chain and the alkene, cis will be Z. Put any other groups on the double bond, then you got to do further analysis for E and Z. Okay. Z works up here. And we finished off with chapter 11, ethers. This page getting a little big. I will be posting these as individual items at Moodle. The videos will be on YouTube, I'm pretty sure. But you'll have links to show you with today's date how to get to those videos. Okay, ethers. In fact, just to make things look a little cleaner, let's take the bottom part here. See if it lets me do this. Yeah. Just so things don't get all smushed in the last or this page. In chapter 11, we studied ethers. Okay, let's do some simple ethers. You got that one. Got a couple options on this one. This option that ends with the word ether is nice because you just have to name the 2 groups alphabetically. It's a little like we did with acetylene. Separate with words. And here we have an ethyl, starts with an E. And here we have 1, 2, 3, 4, a butyl. Butyl will go before ethyl. Butyl ethyl ethers, nice. Using the more systematic name, this is the longest chain, goes 1 to 4. It's a butane molecule with a group on carbon 1. This is all UPAC. It's going to be one word. Note to self, work on E's and H's. All right. One, it's not an ethyl group anymore. Ethyl group attached to an oxygen. And that's pretty much how it gets named. Ethoxy. It's not a separate word. All one word. So ethers, couple options. Let's spend too much time on that. How about those cyclic ethers with the triangle? There we go. If you remember, cyclic ethers with triangles are called epoxides. We use epoxides a lot in this course. They're useful in synthesis. So if we're going to use them, we have to know how to name them, of course. And you can name the triangle part, much like you did with the word ether in the previous example. You can end it with this word here, oxyrain. And that covers just the triangle. And you're going to tell me there's a propyl carbon. It's not carbon number 1 of the triangle. You got to remember it's a ring with an atom other than hydrogen in it. The atom other than hydrogen is number 1. And I'm flexible here. You can go 1, 2, 3 clockwise or counterclockwise. Both put a group on 2 and a group on 3. If you had flipped those, you would just have different numbers in your name. That's a butyl group on 2. 1, 2, 3, 4. 2 butyl. And on 3, it's a propyl, alphabetical. 2 butyl, 3 propyl oxyrane. Unlike ethers and acetylenes, this is one word. We have stereocenters on 2 and 3. And I'll just do the one on, I'll do the one on 3. I'll give you the answer for 2. It's an S. You can work that out on your own. 3, just a quick little review item. Let's do the numbers in purple. You get an O with 1. Carbon with an O is a 2. Carbon without an O is 3. Hydrogen's 4. And you connect 1, 2, and 3. It goes clockwise, but the number 4 group's on a wedge, not a dash. So the wrong answer is R. Therefore, the right answer is S. Okay. You can only do that with the number 4 group on a wedge. When you're reviewing epoxides, please review how they're made. They're always made from alkenes. And they can be named after their parent alkene. Do you notice this is a dash and a wedge, which makes it trans? That also means it came from a transalkene. Let's name the transalkene. This is trans 3. Is it octene? No, it's not 3 either. It's 4 there, isn't it? It's not even octene, is it? 4, 5, 6, 7, 8 is octene. Thinks they're the same. Okay, trans. Trans 4-octene. So you can name the epoxide after that. Trans 4-octene. New word at the end, separate word, oxide. That's a D. That's a terrible D. D's and H's and E's need work. So the full answer is right there. On a test, if you were asked to name them and you gave me this name, I'll give you a full credit. This one's got a little more information though, because trans 4-octene oxide could be this one or it's an enantiomer. You have to agree with that, right? And this one tells you which specific enantiomer it is. So there you have it. And that is a summary of all the nomenclature we studied in in Orgo 1. And that is our 4th segment for today. And I'm going to go slow this time so I don't mess up. That was a pretty serious mistake. Day 1, I've got to try to forgive myself. You please forgive me. I've got to do a stop share first. And then I can end it. Oh, so simple. All right, guys. See ya. Stay tuned for this video being posted and all the other ones. Thank you. See you Wednesday.